And good morning all, and welcome to DevOps Europe. Thanks for joining my session. I will talk about security in a DevOps environment and the things that you need to take into account when we talk about security when talking about DevOps. The title of my session is called The Fifth Element. And why did I choose this title? Well, if you ever seen the Luc Besson movie called The Fifth Element, you know that there's a scene in the movie where the archaeologist is cleaning up the hieroglyphics, and he's reading a little text, and in there he translates actually. In their position are the four elements of life: water, earth, fire, wind, and air. And these elements, when they are gathered around the fifth, the supreme being, the ultimate warrior created to protect life, will then appear. And this is a little bit what you should take a look at from a DevOps stance, is that security becomes the fifth element inside of your pillars around everything which is related to DevOps, going from design, building, deployment, operations. Okay, so this is what this session is about. I hope you will enjoy it. Let's get started. First of all, maybe a little word about me. I'm Mike Martin. I work for Microsoft as a technical evangelist / cloud solution architect. I typically work with customers and partners on these things, and I have some experience in that field where I guide everybody into these best practices that we have. If you want to join me on Twitter, or if you want to email me if you have questions after this session, please feel free to reach out to me. These are just my contact data, so please reach out to me if you need it. So the journey that I'm going to take you through is I'm going to start off with secure design, which is a very important part in the application lifecycle and secure application lifecycle and secure DevOps way. And then we're going to go over to some tools and tricks that I'm going to show you for secure coding. And then we take it up to the secure build part, where we are more into the automation part. And in the end, we're going to go into the secure deployment, where we talk about the monitoring and the operations part, where Dev and Ops meet, and where we have the continuous feedback and the things that we can do around those. So there's this thing called the security development lifecycle, and this is nothing new. Everybody should know this. But the goal of a security development lifecycle is to do a full shift left. Shift left means that you have more responsibility from the beginning of your lifecycle when it comes down to security. So today we see typically security at the end of the life cycle, where we just are doing the hardening part of environments and infrastructure, but we never take a close look into account when it comes down to the beginning, the education of the end user, meaning developers, but even the designers and the people that are working on a product that you're building. So the SDLC is an important thing, and one of the things that are very important is train your people. Make sure that everybody knows security, at least from a little part. Make sure that everybody is aware of risks, that you create awareness amongst users and end users and developers and operational people, and that you also re-put those in the requirements that you do and that you gather when developing new systems. This entire security development lifecycle goes from training into response management. In between, you have all the processes that you need to guide product teams to meet the requirements that you set up for your product. We talk about design, implementation, verification. And then for accountability, you also have the release, where you do constant monitoring. And if something really goes wrong, you need to have a decent incident response mechanism. For those, we just released Incident Response Playbook by Microsoft. It's a free tool that you can use to set up these requirements. So you can actually go there and take a look at these playbooks and try to implement the things that you can do to mitigate and to respond to when you have serious security incidents. Now, some of the best practices that are in there is, first of all, as I already mentioned, talk about training. Train your people, get them up to speed with knowledge. But the other things that are very important are make sure that you do decent threat modeling. Make sure that you do static analysis security testing. And for those who don't know what that is, it means that you need to test your code against vulnerabilities inside of frameworks, codes, whatever, right? And then afterwards, also perform dynamic security testing, which is very important. Once you go live or before you go live, you have to actually validate the implementations of your code that you did and make sure that nobody can actually breach through. Yeah. Do penetration testing. That is not the same as penetration testing. Penetration testing is validating the environment that you have and making sure that you don't have weak links inside of your structure. And then, of course, make sure that you also do the risk management, third-party components. All of these are very important. The things that I'm going to talk to you about in this session, I will actually rely back on these 12 elements that you find that you might find very interesting. So let's first talk about secure design. Now, secure design is not about making sure that you have just only things like HTTPS, but also from a code perspective, you need to make sure that you can implement the correct things. Now, first of all, I work for Microsoft. I might sound a little biased, but it's not. I am looking from this at a stance in the distance, even before I was working at Microsoft. But Microsoft has created some great free tools that you can use to just avoid some of the pitfalls that you may encounter. And one of the things that they invented is a couple of years ago, actually end of the 90s, where there was this acronym called STRIDE that they came up with. There's actually two, STRIDE and DREAD. DREAD I'm going to talk to you about in a second. But STRIDE is an acronym which stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, which actually puts in a nutshell all the things that you can evaluate against when you're designing a piece of software. And to give you some examples, elevation of privilege, you might have a user that you can then spoof against and maybe try to tamper with the system and then give it more authorization parts. Like, for instance, you have a non-admin user and you go into the system, you find a weakness inside of the system, and that way you can give that same user, just a low-level user, more privileges, more admin functionality into that system. And that way you can have a chain of attack, and before you know it, your entire system can be breached. So that's a little bit the way you should look at it. Now, these six acronyms, these six elements can actually help you design a system. And for those, we're gonna score them against DREAD. And these are the things that could happen when you have one of these six. So DREAD is actually the scoring against one of these six elements. It's a damage potential that you can have, but also the reproducibility. So how many times can this be reproduced, and how easy is it? Even the exploit gets a scoring, and the number of affected users, and the discoverability. Is it plain in the open? Is it just an API that you referencing in a different way, and before you know it, or is it just something really, really well hidden and that you don't even know that? Okay, so there's a big difference here. So when we talk about threat modeling in a simplified way, we actually can say, what are you building? That's the model. What can go wrong? That's the threat identification. What are you going to do about it? It's the mitigation. And then did you do an acceptable job at 1 to 3? So that's the validation part. So all these things together is actually threat modeling in a nutshell, keeping into account the STRIDE and the DREAD part, and then you can start building your threat model. Now, this sounds very, very hard to understand. There's a good book about it called the Threat Modeling Book that you can read for free. I advise you to read it if you have the time. But I better show you something of a tool that can help you with threat modeling. And for that, we have TMT, threat modeling tool, which is a free tool that you can download. It's just a click once installer that you have. Yeah, I put the QR codes on the PDF that you can download for my session, and also on the screen, so you can just use your phone and download it from there. And how does this work? Well, I actually have it open here. And let me just go there. So what we have is it looks a little bit like a visualizer, like you have Draw.io or you have Visio, where you just draw and design your solution. Now, very important, if you're drawing your solution, don't think of it as interfaces that you need to draw to each other. No, think about the logical data flow where your data is going from one part of the system to another part of the system. So to give you an idea, don't go drawing, yeah, I need this API connecting to this API. Now connect from, I have a user, he goes through a browser and he needs to authenticate against Azure Active Directory or Auth0, Okta, or whatever you have. Okay, and think of it from that stance. And then it connects to a database. You don't have to worry about the queries that you're doing. You just need to think about the things that you're connecting to. So this is a little bit what it looks like. And when you then take a look at it from that stance, like for instance here, I have an operator who is going through a browser to an Azure web app, and that web app is connecting to an API. Now you see that I can highlight these things, and you have all these different properties that you have here. And all these properties will actually get you that dread and stride calculation behind the scenes. So if you take a look then at the connections that you can make, you can see that I have an HTTPS connection. I can set all these properties here, and that's pretty nice. And you can draw all these. You have all these different Azure assets that you can use, and we should probably change the logo because we did that last week. And you can just drag and drop them on here. Now you say, okay, this is nice, this is just a drawing. But the real power comes down when you go and take a look at the other view. And this is the analysis view. So this will analyze your system and gives you all the different, and here we have it, all the different stride elements. As you can see here, the category is actually one of the stride elements that you have. So you have, for instance, this one, we have a potential process crash or stuff from the Azure portal, for instance, which could be a denial of service. We also have, for instance, here spoofing. So the spoofing the public web app against application insight. So these are all the things that can happen. Now, this is based upon an Azure template that Microsoft built to help you design safer Azure solutions, but there also exists for other parts, because we have, like, for instance, if you do file new, you can do a new model, you will actually see this. No, wow, that's let me just reopen this one, close model again. So if you take a look at the new model, you can actually see that you have a threat model here that you can view. You have an SDL knowledge base model. We also have a medical device model that we have today. And since it's open source, you can actually design your own threat models for that templates, and you can start building it off. So let me go back to that one that I had to open just to show you. There we go. So opening. There we have. And once you have that, the cool thing about it is that it will actually give you a full report that you can then just export as an HTML page that you can then embed in your wiki for your developers. Let me just go and put this on the desktop. So that's DevOps Europe. And then you can use this in your wiki as your guidance and mitigation checklist to mitigate all the security risks that may appear inside of your environment. So here we have it. This is our threat model that we have. So it will generate all the parts of the drawing. It will generate the specific parts of the drawing, so the highlights of the different scenes that you have, the interactions of authentication flow, and all these things. And you can use this as a mitigation checklist to see and validate all the things that you can do to secure your code for the design, that is. Now, design is one thing, but as I mentioned, we should focus on a shift left. And shift left is actually giving the developers a little bit more responsibility and making sure that they are aware also what they are doing. Now, as I said, training is very important, and you should never rely on that people know everything. So we also have some things here that we can help. First of all, I'm going to talk to you about secrets. And secrets is the worst thing that can happen inside of your code. People can just implement API keys, tokens, secrets of to accessing a database or something. And these are the things that you should never put inside of your code. Now, we have some NuGet packages that can help you set up the security better for instance, .NET. There's other packages too for other languages. But the best thing that you can do is implement a kind of a secret manager. And if you're doing Azure development, so Azure Cloud development, the one thing that you should implement is Key Vault, and use Key Vault to manage your secrets and put them in there. And that could be certificates, that could be tokens, that could be authentication tokens, API tokens, whatever you have. And you should put them in there. So that way your code should never, ever have access have immediate a secret implemented inside the code, hard coded, neither in web configs, neither in JSON files, whatever. You should always try to avoid it at all costs. So the key configuration package can actually help you do this. This is for .NET Core, but there's also packages out there that can do the same, just to give you an idea what can possibly go wrong. Now, if it does happen, you need to make sure that you do find those keys. Now, today, a lot of people are using, for open source, are using GitHub. We, at GitHub, we identified this threat, and we made sure that there's a credential scanning inside of your GitHub repositories, public repositories. So if you have a repository where you accidentally put in a credential, we will actually notify you by mail saying there's an issue. Make sure that you take out this key, and we will then put that away. So that's a little bit how it works. Now, in the more advanced security mechanism of GitHub, we also put this mechanism, and we actually give this as a pull request feature. I'm going to show you this in a minute. If you're still using Visual Studio 2017, it's better to upgrade because of security reasons also, because there's always patching and these things going on. But if you're still using 2017, there's a nice toolkit called Continuous Delivery Tools for Visual Studio, which will actually scan this from your code immediately. It's a Roslyn analyzer that will do that. So let me just show you quickly what this looks like from a GitHub perspective. So I have my organization here. Now, I have a GitHub repository here, and there's this security tab that you have. Now, this is for a private repo, and I have a paying subscription, and this is the way we handle it in the background, but you don't see this as a public repository. So you see this little thing here called security scanning alerts. If I click this, you will actually see this, that I did a very stupid thing. I checked in a full connection string with my database, which is okay, but also, and which is much more stupider, is the user and the user and the password that I'm using to connect to my SQL database, which is a bad thing. Now, you can try hacking this thing because that database no longer exists. It's just a fake dummy key, but you get the idea. So from here out, you can actually just create a pull request and make sure that this will be deleted and will be put out of the system. So it's very important that you realize that checking in keys can be very dangerous. There was this thing a couple of years ago where S3 buckets keys were appreciated keys of S3 buckets, so storage containers from AWS, were being used to find a weakness inside of the same subscriptions of that AWS to do Bitcoin mining. So you can see it can have a very potential high risk for yourself in cost too, because they were then just launching VMs to do Bitcoin mining on their behalf. So that was really not a fun thing to have. Keys is one thing, but also secure coding elements and secure coding knowledge is very important. And we do understand that not every developer is really, you have junior developers, and not every developer is really up to speed with all those things, and that's fine. As long as they know that there is a risk and they're open with that mind, that's already a good thing. But we do have some things that can help you with. To give you an idea, we have this security intelligence extension that you can have for both Visual Studio and Visual Studio Code, where you can actually take a look at a Roslyn analyzer that analyzes against the classes and all the code that you're writing in C#. Now, if you take a look at it from a perspective of Visual Studio, full Visual Studio, I can show you that. You will actually see this. So I have this sample application here where you can see, and you see all the squiggly lines. It will show you immediately the potential security issues. Like here, I have an authentication context, and the custom token cache is identified. So make sure that it handles and that you don't need any caching. There's like really a high priority, meaning by if it's an error, then it's high priority. If it's an exclamation mark or a warning, then it's just informational or just even a good thing to fix. Like for instance, here, if I press this one, you will actually go through the documentation of the thing and you will get, oh, and there's a little bug there. And I actually didn't want to press this, but I actually want to click this one. So you will actually see red squiggly lines. You will get a good fix of it. And this will actually help you fix your code and make your code safer. So that's a good thing, right? It's a free download. If you're using Visual Studio, use it. You will not regret it. Right? Another thing that I want to show you is the Visual Studio Code extension. So we talk about this extension that you need to download, and you just can find it into the extension store. There's others too, because there's, like, for instance, DevSkim, which is a very good one, which also does good analysis of your code. But if you just take the security intelligence part, you will actually get the same squiggly lines. You will get a good view of the problem. You will actually see them into the problems down here with a full explanation. Like for instance, here, random is a cryptographically weak random number generator. So you need to use something else with a better cryptography extension on top of that. Even from a service provider, you get all these little hints to improve your code and make shift left happen. Okay. Now, if you're doing coding and you have security mechanisms in place, that's good when you're on the IDE side. But once you're checking your code, you also need to make sure that your end users, your developers in this case, don't have too many rights, and that not everybody has full access inside of your environment. So you need to make sure that your developer environment is also being set secure. That's very important. So make sure that you work by the principle of least privilege, that only those that can contribute. Don't forget about SolarGate, for instance. So the thing that happened with SolarWinds, where their code was injected with a malicious piece of code, thanks to the weak configuration of a user somewhere in their mailing system, they got access to the built-in CI pipeline. And this is how they injected the code. So that's a bad thing. It had nothing to do with the tool itself. It had more to do with the configuration and the low level of security and the not monitoring of that part. So make sure that you actually do that. And you can easily do that in any kind of system, whether it's Jenkins, GitHub Actions, whether it's Azure DevOps, whether it's anything that you're using against it. But make sure that you have a principle of least privilege. Then we talk a little bit about the secure ops part. So once we are there, we have our operations running inside of our DevOps environment. And for Azure DevOps, for instance, we have this nice tool that you also an extension that you can use to check your build system against the security part. So I can actually show you this. I have this dashboard here open. This is an extension that you can just ingest in Azure DevOps. Whether you're using it with GitHub repos or with Azure repos, all fine. Whether you still want to, when you don't want to use it, also fine. But just to give you an idea that there's things that can actually help you. This will actually check for the organization and the project security, but it will also check It will also check for the security of the pipeline itself, of the connections that are using, the SPNs that are being used with the secret, whether they're passing through, and this will actually be checked on a regular basis. So you just implement this into a build, it will check that build, and all will be happening automatically. And then you can use this thing, these widgets inside of the dashboard, where you can actually take a look on how healthy your build environment is. That's from a security part for the coding and security part on the end users. But if you want to do a secure build, and this is where we come into the sphere of the SAST and DAST tooling, we also have a lot of options and opportunities that you can use. There's a lot of tools in the market that you can actually use against. There's Aqua, there's wide sources, things like the OWASP organization that are providing extensions for most of the build environments. There's we that will do our own little things. There's SonarQube. So there's so many things. I'm just going to quickly go over a couple of tools to give you an idea that you can use against Azure and Azure builds and deployments. So that way you can set up your CI/CD build pipeline in a very secure way. The first one that I have is unfortunately something that will be partially deprecated by the end of June, but you can still download it to validate some checks against your ARM templates, for instance. That's the AZ Escape. It also comes, it's the AZ Escape is a full toolkit that you can use. You can implement it into your DevOps pipelines, but you can also use it for the security intelligence extension that I showed you, because that's also a part of it. The dashboard that I just showed you is also part of it. But here, I'm going to show you the PowerShell scripts that you can still use, so you can download these. What you can do here is you can actually check the security of templates, but also the security of your subscription. So I can do a check template security status from an Azure resource manager template that I have here. What this will do is this will check against all the different things that you have defined in there, and it will check for failed or to verify medium, high, and low security risks. And then it will generate an Excel file, actually a CSV file, where you can just start looking at all the different problems that it encountered, and you can use that as a mitigation list. It can also check your full subscription. I'm just going to start this, and you will see that it will do a lot of things in the background, and just leave it running there. But you will see that it will actually start. Oh, I took the wrong line here. Let me just quickly fix that. Here we go. Here we go. So if I'm running this now, it will check against my full Azure subscription and check against all the different risks that I have mal-implemented. So this will also help you a little bit from a DevOps part, because you can just use these with the extension in Azure DevOps or in GitHub Actions, use the PowerShell command and just check against that and use this as a gated feature, for instance. Talking about ARM, you also need to make sure that you have a good validation of your ARM templates and other things. Are you using the correct APIs, ARM APIs, the latest version and stuff? And for this, we have another PowerShell toolkit called the ARM template toolkit, which is a very cool way of checking whether your template is valid against not only against security, but also against the correct usage of the APIs. So here we have it. Let me just quickly show you this. So I have a test AZ template that I can just use. Let me just clear my screen here for a second. So I can just do test AZ template. There you go. If I run this, it will also check against best practices. It will check against the API versions, as you can see here. So red is older APIs. Now this is just a sample template that I have. So if I would have built a very clean template, this would be a minimum of red instead of a maximum for it. But for demo purposes, this is very, very good. And as you can see, there's some don't do hard-coded URIs, don't do all these things. So you get a lot of feedback on this system to see whether you created very nice ARM templates when you're doing Azure development. So that brings us to implementing SAST checking. So there's a couple of free tools that you can use on the market. There's one of my favorite, there's two favorites that I have. This one and the next one. The next one is even more favorable. First of all, there's White Source Bolt. Now, White Source Bolt will check against all your packages and dependencies that you're using, first of all, on a license perspective, but also on the vulnerabilities that it may contain inside of their packages. So there's a lot of dependencies that we're creating in our code. And if we check against those dependencies from a package management perspective, we will actually minimize the weaknesses in our systems coming from a third-party system. So one of the things that you can do is implement these actually in either GitHub Actions or in Azure DevOps. And if you take a look at it from an Azure DevOps perspective, you will actually see that after a build is done, you will get a nice build report where you can actually get a full explanation of all the packages that you're using, the CVEs, which is a international standard for highlighting vulnerabilities that exist inside of packages. And this is a managed list that is being withheld from a non-profit organization where everybody can just use these and get their scanners validated against. So here you can actually see that I have a CVE in a library from a JavaScript library, and you will get recommendations on how to fix these. You will see that I have 7 highly vulnerable systems. So you get a good overview of the security part of it. If you have the paying version of White Source Vault, you get all these nice reports, and you can set back all these different security parts here. You can just drill down into, oh, yeah, okay. So apparently I got a timeout session, but that's okay. Let me try that again. That's what you get when you prepare a lot of things. There we go. And then just wait. So you have a good reporting overview. You see all the different things that are very, very important, which can be very vulnerable. You can click through, and then from there you can just implement that with your CI/CD and also with your code flow, your Git flow, for instance. Another tool which is really, really nice and which I like a lot, where a lot of effort is being done in creating great security, is Snyk. At Snyk, they have scanners that you can implement on the IDE for Rider, IntelliJ, but also for VS Code. They have a very nice extension now available for VS Code too. And there's a lot of free buildments that you can use against. They will check against the CVE parts, but also a little bit of your code sanity. And it integrates very nicely inside of GitHub Actions in Azure DevOps. If we take a look at it from an Azure DevOps stance, you will see again my same build thing, that you have a nice Snyk report at the end. And you get all the different elements that are failing. So regexes that can do denial of services, and all these things, arbitrary code execution. So this is a very nice report. And it's fairly easy just to implement these things, because if you just do an edit here on my pipeline, I can just do a, in Azure DevOps, I can just do add that task just by dragging and dropping it. As you can see here, it's just adding these little tasks here. In GitHub Actions, it's just the same thing. It implements very nicely, and you can even just have Snyk scan your repos at top. So you check in, it will get automatically scanned on that level. Pretty cool. The dashboard part with the integration on Snyk itself, as you can see, there's a lot of pending tasks here too, and you can do these with all these different integrations for all these different systems. It works with Jenkins, it works with GitLab, Bitbucket server, even GCP. Very cool stuff that we have there. Now, it's not only about secure code, it's also about technical debt. And one of the best tools to manage technical debt and manage code quality is SonarQube. Quickly going to show you this. So SonarQube has a lot of features. You can either run it in Sonar Cloud, which is a hosted version. It comes for free up until 1 million lines of code. I just have my demo here. As you can see, uploaded a demo report here where you can check all my vulnerabilities, and it will give you a good security warning and overview. You can even see the OWASP top 10 things and all the CWE and SENS top 25 security categories, if they are. And if there's none associated, you will see it differently. Or you can host it yourself, which I'm doing it into an Azure website. But you can run it into a container inside of a VM, where I can then just go and take a look at my thing, and it looks just the same. The only thing is that there's little less of a limitation here because it's a community version. You can run it yourself, and you got all these nice features going on. As you can see here, oh, that's weird because it passes. Yeah, the last run, yeah, that's normal. But it has security hotspots that you can see, and for some reason it's not loading. Okay, let me just. There we go. Takes a while. All the security hotspots that you can see, you get all the reviewing parts that you need to do. You get code inside here. As you can see, there's password in here. So these are all very nice help of things where you can have a good overview of your code quality. Now, as I said, technical debt is also security issues and vice versa. So make sure that you are aware of those things. All right. The next part, let's talk a little bit about secure deployment, and then we're almost finished. Again, make sure that if you're doing deployments, make sure that you do them well. Follow the principle of least privilege. Again, make sure that your deployment system doesn't have full access inside of your cloud or whatever landing zone that you have. That's a general thing. But in Azure, make sure that you're using RBAC and that you're using policies. Make sure that you have blueprints set up for these things, so you can actually use a blueprint to set policies and security rules and RBAC on top of those, together with your templates that you're deploying. So that way, your blueprints and your policies will actually block certain kind of deletions or updates that you're not allowed to, and that only those users with that specific authentication authorization part can actually do those things, right? That's a little bit the goal. There's more slides in the PDF that I'm sending you to explain you all these things. For the lack of time, I'm just going to show you one more thing when it comes down to the monitoring part, which is typically the part that is forgotten from within a DevOps lifecycle. Is once you're in operations, you need to have continuous feedback, but also from a DevSecOps part. For that, there's a tool called Azure Security Center, which can help you very nicely. Now, we have this thing called Azure Defender for Azure Security Center, which we can actually check against all the resources that you're deploying inside of Azure. And one of the things that we do very nicely together with a scan agent called Qualys, scanning against the images that we're putting into the container registries, which you then can use to deploy your containers inside of Kubernetes or in apps or in ACI, for instance, and container instances. I'm going to quickly show you this, what it looks like. So in Security Center, we have Azure Defender. And if you click on this, you get this nice overview window. And we have this container image scanning tool. Now, you will say, yeah, but once I already push my container in there, I know you can scan against the vulnerabilities, against the images that I built. But isn't it too late then? True. But you can actually use this information once the image is in there to validate against the security checks and the issues that we have. Use resource graph to push that back into your CI/CD system. And if your image hasn't been fixed from the previous deployment, your image will not pass. So you can use this as a gated instance. And then from here out, you can actually see from the monitoring part, if it still gets through for some reason because you don't know it, you can actually take a look at all the different images that are impacted here. You can go from here to the CVEs that are managed here, and you can have even some remediation here. Like for instance, here Debian Security, you will see that there's a remediation to update to Debian 10 or 9. There's also like users with a blank password here. You set the password for all the users, so you get remediation tools. So use this maybe against the development environment and development subscription, and then use that feedback inside of your go to live production. Very, very nice part. I don't see any questions, so that's good. If there's questions, feel free, right? Last thing that I'm going to talk to you about is the advanced security parts that we have in GitHub. Now, GitHub is part of the Microsoft family, and we did a lot of effort there to move security more to the developer side. And just to show you all the things that we have today, there's a lot of security features that we have. First of all, we have Dependabot, which will also do dependency checks on your environment. And it will give you pull requests on top of your all your different weaknesses in regards to dependencies. So you actually get the same CVE information back inside of your GitHub repository. We do code scanning. And for this, we bought a small company called Semble. We revamped it inside of GitHub as CodeQL. And you can easily set this up, this code scanning, if you have advanced security. You can easily set this up by using GitHub Actions, which is a workflow. And I already have this one here. as you can see. And this will actually check against the language that you have implemented inside of your repositories. And if that build then is being kicked off, you will actually see a full analysis. You see an analysis of some lines of code that are not in the database, and you can actually go and take a look at that full job, which it does. And then you can have a full analysis here, which you can then say it's analyzing these scripts. And these are all the things that it will identify, that you can identify against. It's using these plan queries. So these are all in the centralized database that will be read, and we will validate your code against those weaknesses that we find in environments. And then it will generate PRs for you, pull requests, both Dependabot and both CodeQL can generate those for you. So it will help you make your code a little bit more sound, and it will give it a label from that perspective. I also mentioned the code scanning. You can set your own security advisories here, and you can even set a policy that the least security features that you need to implement when you're doing a new fork or a new implementation of a part of your code. Okay, is that all that you can use? No, there's a lot more. Now, at the end of the line, I have some references there and some resources for you, some labs that you can do where you can learn about implementing a more DevSecOps way of pushing into code. But there's one thing that I didn't implement here in my demo, because it takes too long to explain, is DAS tools, so dynamic testing tools. And this is something that you usually need to show in a full demo part. But there's a lot of free tools on the market and paying tools on the market that can actually do dynamic automated and security testing. One of the things that you can do is use ZAP for that. There's the vulnerability scanning tools in the OWASP environment. Portstrigger is also free, but ZAP can actually be implemented as a small container running inside of a website. Inside of a website, you reroute all the information of your website that you deployed or you're going to deploy. Inside of that ZAP, you'll get a full GUI reporting feature out of it. It's really, really cool, but you get a good feedback on, yeah, you should close those ports. You should not implement this line of code because that is SQL injection, and so on and so on. So all these things can actually come back by validating against OWASP top 10 features, and so on and so on. So I'll leave this for you reading. This is all in my slide deck that you can find after the session. And that's it. I'm done. I hope you enjoyed my session. I hope you learned something. For me, the most important thing is to get out of the session when I'm delivering it is creating awareness and realize that it's not really hard to implement something like these. I gave you a lot of good pointers on how to start easy and simple with these things. So this will actually give you a good idea on how to start with DevSecOps. Okay. If there's any questions, I'm still here for a couple of minutes, and if there's no questions, then I'll just wish you a very nice and pleasant continuation of DevOps Pro, and I hope to see you in real life anytime soon. This pandemic has taken long enough, so let's hope that we can move from virtual into real life conferences again really, really soon. And yeah, hope to see you in real life. Okay, no questions then. All right, I'll just leave you to it. All right, see you all then. Bye-bye.